So, how many of you love optimizing your data? Show of hands. So, you guys are in for a treat. So, we'll first quickly talk about profiling and then see how we can use these techniques to optimize performance of our React app. So, how many of you have been suffering from performance problems with your React app? Quite a few. So, we'll not talk about advanced level stuff there, but some of the basics of React and how they can affect performance. So, a bit about myself first. My name is Sachin Chopra. I work as a software engineer at Chopra. So, my primary passion is building performant web apps and making web apps as powerful as native ones. You can reach out to me in one of these mediums. Okay, so let's say the facts first. React is fast, right? With things like simple declarative API, virtual DOM, efficient diffing algorithm, sensitive events, fast and prioritized updates with Fiverr. React is one of the fastest libraries to work with. But still, performance can suffer in React. And the primary reason is consistency and bad design and architecture, which makes React do more work than is actually required. Other cases could be you have a genuinely complex UI where large parts of DOM are being updated very frequently, or your target audience is using very low-end devices, so that even the most performant apps will feel sluggish. So today we will primarily focus on point one and how we can fix performance in this situation. So we will first talk about what are some of the common profiling techniques, and then use them to fix issues in our demo application. So first, why do we need to do profiling? Why can't we just read about optimization techniques on Medium and just directly go and put it there in our app? So the first reason is profiling helps us to optimize premature optimization. With profiling, we can identify what are the actual bottlenecks in our UI rather than randomly fixing here and there. Secondly, they say you cannot optimize what you can't measure. So profiling also gives us some amount of quantitative data around the performance and helps us in analyzing the cost of our optimizations. So there is actually a term for this called armchair profiling. If you are not doing proper profiling and not measuring the data, there is a term for it, armchair profiling, and this is a vision for it. A tweet by Michael Jackson, it says, just bugs me when people lean back in their armchair and go, that code looks like what could be slow to be, without measuring anything. So proper measuring and proper profiling is key to optimizing the performance. So let's see what are the common profiling techniques which are available to us. So we'll start with core performance tab. This is one of the most powerful techniques which you can use for profiling your application. It's very simple to use. Go to Chrome Dev Tools and then go to Performance tab and then click the record button. Once this is done, you can simulate the events which you want to profile. Once it's done, stop the recording and we are ready to analyze the results. So I'll show you a demo regarding this. Let's say this is a sample app. I'll explain the workings a bit later. Let's say this is just an app. I'll open Chrome Dev Tools and go to Performance tab and start recording. Now I'll add one of the products to cart. Stop. So we can see we have a huge report here which we can use to properly analyze the performance of our web apps. So what we focus on today is first the scripting section on the top, shown in point 1 here, which is where most of the JS magic happens. So once we narrow down to the scripting section, we can move on to the user typing section here. So starting from React version 15.4 onwards, all the React events are come to the performance time. So you can see all the re-rendering which is happening and all the lifecycle hooks which are being fired and the time which is being spent on them. Are you note that since we are doing this with development build, the numbers are related. These are not the numbers which you will see in your actual performance. Second, Chrome plugins can also impact the performance. Next, let's talk about the user timing API. So in the previous slide, we saw how we could see all the React events in user timing section. What if we want to see our own custom events there? The answer is user timing API. So the user timing API allows you to mark custom events on the browser's performance timing. This is supported on Chrome and is available in Safari's developer preview, while work in Firefox is in progress. So the main API which you have to use is performance.mark and performance.measure. So performance.mark places custom timestamps on the performance time, and then you can call performance.measure within two custom markers to mark that event on time. Let's see this with an example. Let's say in our e-commerce app, we want to analyze what happens when the user clicks on add to cart button and the product actually becomes visible in the cart. Right? We want to analyze what all React is doing in this time. So on our add update function, we can place a performance marker calling add to cart link. Then we can place a second marker when the cart is actually updated. Performance.mark cart updated. Then to show the time between these two custom timestamps on per timeline, we can call performance.measure, name of the measurement, and the two markers between which we want to measure. These places in a try catch block because if one of the markers is missing, it throws an error. So if we profile after this, we can see that an add to cart is visible here in per timeline. So now add to cart is visible in per timeline, and we can drill down further to see what all happened in this time frame. This was this. Some other handy tools which we can use. React browser extension, and specifically the highlight updates button here. This basically highlights all the React components that are being re-rendered on some particular action. So let's say this is a sample form. Whenever you click on show and hide update, you can see all the components which are being re-rendered are actually being highlighted with custom colors. So this gives us a good idea about what all we can optimize in our app to prevent unnecessary re-renders. You can also use Chrome DevTools paint flashing to see which all parts of long nodes are actually being read. So we talked about performance time, but that is available only since React version 15.4. So if you are on React version older than that, you can use something called as React perf addons. This is an excellent tool. It's pretty simple to use. You can just include it in your code and then call perf.start to start profiling and perf.stop to stop profiling. Once you have the profiling data, you can use methods like print wasted, print inclusion, print exclusion, and print doc to analyze the results. Please note this is not supported from React version 16 onwards, so please only use it if you are on version older than 15. This is what a sample screen looks like. After calling perf.start and perf.stop, we can use methods like print wasted to see where all React ended up wasting time. Which component, how much time was wasted, and how many steps. So this is a good tool to use. So we have seen some of the common profiling techniques. Now, how can we fix problems using these? So when we profile our apps, the most common causes which we will see for degradation in performance are either a long time is being spent in reconciliation of the React or too many unnecessary re-renders are happening. Let's see this in our demo app as well. So this was the result which we profiled earlier. I'll zoom in slightly more. We can see here a lot of time, around 200 milliseconds being spent reconciliation of the React, and a lot of components are being unnecessarily re-rendered. For example, all these product type components are being re-rendered on add to cart operation, which is actually not important. So this is the demo app that we are using. This is how it's structured. It has data of products arranged in its state and this array of shortlisted items, which are basically items which are present in the cart. We are calling map on data to render all the products and then passing shortlisted items to cart to render data in the cart. So this will be the diagram or the architecture of the sample or demo application which we are using in this video. So we saw a lot of time was being spent in reconciliation of the reality. Let's basically understand first what reconciliation is. So whenever a component's prop for state changes, React generates a new tree of React elements and compares it with the previous one to transfer the updates to the actual UI. This process is known as reconciliation. Reconciliation is basically a problem of converting one tree to another with minimum number of operations, which is actually an order of n cube operation, but React does it in order of n using certain heuristics. By properly providing these heuristics to React, we can speed up reconciliation and reduce reuse. So one of the ways which we can use to speed up reconciliation is by using should component update, which is a lifecycle. If you return true from should component update, the component renders and follows its default path. But if you return false from should component update, the component and the entire tree of React elements rooted at that component is not re-rendered and no reconciliation happens for them. Thus, it saves significant savings in reconciliation time. So let's consider this is a tree of React elements C1, C2, C3 till C8. Let's say we want to update node C7. So data is going from C1, C3 and C7. Thus the most optimized update in this case would be to re-render only C1, C3 and C7 with the new data. But in React, if you are not doing any optimizations, what actually happens is the entire tree from C1 to C8 will be re-rendered. Thus, we can use should component update in this case and return false from C2 and false from C8 to optimize our re-rendering logic. Thus, we will be able to achieve the most optimized path in this scenario and have significant savings in reconciliation time. To use should component update, you can use React.pure components, which is equivalent to implementing a shallow comparison of current and previous state and props. So let's see if we can use should component update in our demo app to optimize the performance. So what I have done now is I have added a should component update here and I am doing a shallow comparison of current props and next props here and returning true or false accordingly. So let's see if this solves multiple re-renders of product in our case whenever we add a product to cart. So I'll refresh this once and clear the perf timeline. So let's say I add a product to cart. One more thing, so I have actually given random background colors to the product. So whenever the products are being re-rendered, their background color is changing. This gives us a visual clue that an actual re-render is happening. So we'll start profiling, add a product to cart, stop, and let's see. We'll move to the scripting area. Okay. So we can say we are approximately taking same amount of time. We don't have any significant savings here. And all the components are actually being re-rendered again. So looks like our should component update implementation is faulty. Let's see. So So what we have done here is implemented a shallow comparison. Let's see what props are actually causing this shallow comparison to fail. So what I'll do is, I'll have a console.log here to basically log which all props are failing the shallow comparison check here. So I'll go back, refresh. Okay. Add a product to cart. Move to console. So add to shortlist and keywords. These are the two props which are failing the shallow comparison check which we have implemented. Let's see what we are passing in these props. So in add to shortlist, we are basically passing an arrow function, and in keywords, we are basically passing an array reference. So these are what are causing the problems. Let's see why we cannot do this. So passing arrow functions or bound functions and props actually fails the shallow comparison. This is because a new instance or function is created on every render. Thus, the shallow comparison in should component update or pure component fails. Similarly, we cannot pass object or array reference in props for the same reason, because a new instance will be generated on every render, causing the reference step to fail. This also causes unnecessary creation and deletion of objects. Thus, we should avoid this. So we'll go back to our app and we'll remove the arrow functions from here and the array reference. So I have changed this to a normal function here now, and actually I'm using the new ES6 class function syntax to bind it at the very top. So let's see if now our performance is fixed. Refresh. Here. Add the product to cart. Okay, so background colors are not changing. Let's see the perf timeline. Start recording. Add to cart. Stop. Oh. So we have moved from 200 milliseconds now to 56 milliseconds. So a significant saving just by implementing should component update. So in our app we have two operations basically. Add to cart, where we can add product to cart, and remove to cart operation, where we can actually delete product from cart. Let's see how our remove to cart operation is working. So what I'll do is, I've added around 50-60 products to cart by default, so that we can easily visualize the performance. Go to inspect. Okay, so this time let's use the highlight updates, the other tool which we discussed. I'll click on highlight updates and try to remove a product from cart. Okay, so the entire, so the rows below the product which I am removing from cart are being highlighted. Please observe, I will be deleting product number 6. So please observe the rows below product number 6, and you will see they are being highlighted. Right? Let's also see this in perf tab. Let's start recording. Delete the product from cart. Stop. This is where the cart update is happening, and we can see all the cart rows are being re-rendered whenever I am deleting a product from cart. Not all the cart rows, but the rows which are below the entry which I am deleting. So let's see why this is happening and how we can optimize this. So to fix this, we'll have to understand something about names. So most of you would have seen this warning in React, and it's pretty easy to fix this, right? You can just pass random numbers or indices if you're mapping over to fix this. But that is not the solution. So let's see what is the correct way to solve this problem, and more importantly, why React is so strict about this warning. So keys is one of the heuristics which is used by the React to speed up the reconciliation process. It is used to identify which nodes has changed between specific renders and which have not. So whenever you are generating a list of child nodes, you must give them unique keys. Keys should be stable, predictable and unique. Unstable keys like using math.random will cause unnecessary DOM nodes to be created and deleted and cause performance degradation. Also, using indices does not work if your list can be reordered or entries can be deleted from your list. In fact, if we go back to our previous example, where the card performance was not optimized, I'll show you I'm already passing index as the key here, and still we are not getting the performance benefits. So using keys does not work in all cases. So let's fix this. What I'll do is, instead of passing index here, I have a unique product ID. So I'll pass product ID as the key now. Instead of index, I'm passing product ID as the key. So let's refresh our app. Let's again go back to highlight update option and see. Okay. So now I'm going to delete product 2. Let's see if the rows below are picked are being re-entered. No re-enter, no re-enter. We'll also confirm this with perf tab. We'll open data, start recording, delete the key, stop. So we can see our cart update has moved from around 34 milliseconds to around 2 milliseconds. Again, a significant saving. Right. So now we have optimized add to cart operation as well as remove to cart operation. Can you guys think about any other problem which could be there with this app? Anyone? I'm going to give you a hint. There are around 2000 products in the list. Can somebody guess what other problem we could end up having? Yeah. So, even though we have optimized add to cart and remove from cart, whenever our app loads for the first time, we still end up creating thousands of DOM nodes unnecessarily, when only a fraction of them are actually visible to the user. This makes our DOM heavy as well. Plus, it puts extra strain on the reconciliation process as well. So, let's see how we can fix this. To fix this, we can use a technique known as virtualization. What we can do is we can render only a limited number of nodes to the UI and then reuse those existing nodes to render the rest of the data. This can reduce the number of DOM nodes created as well as save the time in re-rendering as well as the initial render of our DOM tree. For this, we can write our own custom implementation, but here I am going to use an excellent module called React Virtualize to do this. So what I'll do is I'll virtualize my product listing.
So hi Sachin, we have one and a half minute left, so we can wrap up.
Almost done.
Yes, sure, no problem.
So what I'll do now is, let's go to our mobile view, because this is where we usually have problems with large downloads. So I'll go to a mobile view and let's slow down, 6x slow down. So this brings us closer to performance of phones like Moto C+, which is an average range phone. So start recording, refresh the page, stop. Did you see? It's so fast now, even on a 6x slowdown, because we are only creating limited set of downloads here. We can also confirm this with React plugin. Whereas if you see there, we we have only limited number of product type components. Let's say from index 0 to index 13, and when I profile, when I scroll down this list, the same DOM nodes are there, only their index number are changing. That means the same set of DOM nodes are being reused. So we have optimized add to cart, remove to cart, as well as our initial render. So this does cause for some amount of celebration. So you can dance in your mind if you want, not literally. So other recommendations, if you are frequently rendering large DOM nodes in your app, you can explore a trick called memoization, where you can memorize large components so that they are not re-rendered every time. Or you can break your bigger components into smaller chunks so that you have a better control over what renders and what does not. Or you can optimize the build process, use some of the advanced label plugins and all, which modify your code on the go to optimize certain aspects of it. Yeah, so the key takeaway from this talk: avoid premature optimizations, do proper profiling and only then optimize. Do benchmark performance before and after to analyze the impact of your optimizations. Many times the cost of optimizations will be more than the gains. But if I could sum this talk up in one line, it would be: don't make React do more work than is actually required. That will give you kick-ass performance.